irrigation engineer. Every year on his birthday, the Telangana State Center Committee at its meeting held on 24th August 2019 has unanimously resolved to organize an endowment lecture annually at our center in honor and the memory of an eminent engineer, Gurram Koti Reddy garu. He is superintendent engineer retired, irrigation department. Accordingly, the Telangana State Center is organized already first endowment lecture was delivered in memory of Gurram Koti Reddy garu on 23rd 9th 2019. Now we are celebrating second endowment lecture. I am very glad to brief about the Gurram Koti Reddy garu to all the participants. Engineer Gurram Koti Reddy was born on 23rd September 1925 in Tipparthi village of Nalgonda district to Papa Reddy and Seethamma. After matriculation at Nalgonda, he completed BA and BE Civil Engineering from Usman University. After completion of graduation Civil Engineering, I joined in the Tungabhadra project. After bifurcation of Hyderabad state in 1956, he got transferred to the NSP and he was in charge in Chilkarurti Tunnel. He was transferred to Amshadaya Project Investigation Division 1970 as a punishment for his support to the Telangana agitation in 1969. He worked in SRSP as a EE. After promotion as SC in 1975, he is posted as a project administrator of NS Left Canal. In 1979, he is posted to CCH and retired in 1983 after completing Kakatiya Canal from land came 234. And already explained he is married to Susila in 1944 and having 3 sons and 2 daughters. Eldest son Satyanarayana Reddy is civil engineer and second son Dr. Ramesh Reddy in USA. Third son is Pratap Reddy, is computer engineer in USA, and the eldest daughter Aruna and youngest daughter is Geeta. And Gurram Reddy garu, that Koti Reddy expired on 26th 6 2003 at the age of 78 years. He will be remembered as a dynamic taskmaster and able administrator. And we are every year we are conducting this endowment lecture on his birthday at our center. I am very glad to inform that Telangana State Center, the Institution of Engineers, has regularly organizing the almost 17th endowment lecture every year on the birthdays in honor of the eminent engineers. And accordingly, these endowment lectures are being delivered by the people of high eminency with considerable professional experience to throw lights on important emerging topics of today's relevance. Then with these few words, once again, and extend hearty welcome to our chief guest and also speaker, Professor KVL Subramaniam, Professor Department of Civil Engineering, IIT, and to all of you for this endowment lecture. Now, I am requesting Sri V. Jambul Reddy FI, a member IEA Telangana State Center, introduce our chief guest and speaker of today's endowment lecture to all the participants. Over to Jambul Reddy garu.
Good evening, everyone, all engineers. So, I am very happy to introduce myself. I am V. Jambul Reddy, a committee member and former engineering chief of Public Department, Hyderabad Metro Water Supply Sewerage Board. I am very thankful to the Institute of Engineers for giving opportunity to introduce today's speaker, today's chief guest, Dr. KVL Subramaniam garu, on the occasion of Gurram Koti Reddy second endowment lecture. Sri Professor KVL Subramaniam Garu is currently a professor in the Department of Civil Engineering at Indian Institute of Technology, Hyderabad. He was the Dean, Planning and Development at IIT Hyderabad and oversaw the construction of the new campus. Prior to joining IIT Hyderabad, he was a professor and cattle research fellow in Department of Civil Engineering at the Grove School of Engineering, the City College of New York. Dr. Subramaniam obtained BTech in the year 1993 in Civil Engineering from IIT Delhi and PhD in Structural Engineering and Materials from Western University, Evanston, USA in the year 1999. After graduation, Dr. Subramaniam worked as a research associate at the NSF Center for Advanced Cement-Based Materials. Dr. Subramaniam was awarded the Early Career Award from the National Science Foundation of USA for investigating the early age changes in cement materials. He received the James Instrument Award from the American Concrete Institute in the year 1997 for his research on non-destructive evolution of concrete. He is the recipient of the Outstanding Young Researcher Award at the Grove School of Engineering in the year 2006. He was the chairman committee 215 in the fatigue of concrete of the ACA in 2009. He was elected a fellow of the American Concrete Institute for notable contribution of the area of fracture and fatigue of concrete. He is an associate editor of the Journal of Materials in Civil Engineering and has served as an associate editor of the Journal of Bridge Engineering of the American Society of Engineers. He is on the editorial board of the Journal of Cement and Concrete Composites. He is a life member of the Indian Concrete Institute. Professor Subramaniam is currently the director of the Center of Excellence in Sustainable Urban Development of Ministry of Human Resource Development at IIT Hyderabad. He is the program leader for the Sustainable Development Trust in the Friendship Program of the Japan International Cooperation Agency. He is the recipient of Excellence in Teaching Award at IIT Hyderabad in 2011 and 2015. He has served as an advisor to several agencies, including RIDES, RVNI, Hyderabad Metropolitan Development Authority, AP Capital Region Development Authority, APIATSC, US Consulate in Hyderabad, and CPWD, Campus Development, the Kanpur Development Authority. Under Subramaniam Garu, under him, 9 persons awarded PhDs under him, and he has published about 100 papers. Thank you very much for giving this opportunity. I am handing over to the chairman. Thank you for further action.
Thank you very much, sir. Thank you, sir. With the permission of our chief guest, just I want to tell that Venkatramaya SC Irrigation want to say about few words about Koti Reddy, sir. Over to Venkatramaya. Sir, you unmute చేసుకోండి సార్. మీరు అన్మ్యూట్ చేసుకోండి సార్ మీరు. ఓకే, నౌ యూ కెన్ టాక్.
సభకు నమస్కారం అయ్యా, సభకు నమస్కారం.
వినిపిస్తుంది సార్, వినిపిస్తుంది
సార్. సభకు నమస్కారం. నేను కోటిరెడ్డి గారి దగ్గర 1967లో ఒక 1 year పనిచేశానండి జేఈగా. ఆయన లీడర్షిప్ క్వాలిటీస్ అవి మమ్మల్ని బ్రహ్మాండంగా ఇంప్రెస్ చేశాయి. మేము ఆయన అడుగుదాడు నడిచే ప్రయత్నం చేశాము. ఒక చిన్న ప్రాక్టికల్ ఎక్స్పీరియన్స్ ఏంటంటే, ఒకసారి చిన్న ట్యాంక్ బండ్ డిజైన్ చేసి తీసుకొచ్చారు నా దగ్గరికి. నేను దాన్ని అగ్రి కాల, అయ్యా ఇది ఎవాపరేషన్ లాస్ ఎక్కువ ఇది పనికిరాదని చెప్పా. కోటిరెడ్డి గారు దాన్ని శాంక్షన్ చేసి కన్స్ట్రక్ట్ చేసి ఒక 8 నెలల తర్వాత ఎండాకాలం తీసుకెళ్ళి చూపించాడు. ఆ ట్యాంక్ చుట్టూ సీపేజ్ వాటర్ వచ్చి ట్యాంక్ నిండుగా ఉంది. అందువల్ల అన్నాడు, పుస్తకాలే సరిపోదు నాయన, కాస్త ప్రాక్టికల్ అవుట్లుక్ కూడా ఉండాలని చెప్పాడు. అలాంటి మహానుభావుడికి నమస్కారం. చాలు. థ్యాంక్ యూ సార్.
థ్యాంక్ యూ సార్. థ్యాంక్ యూ వెరీ మచ్ సార్. నౌ క్యాప్టెన్ జనార్దన్ రావు సార్ కూడా మాట్లాడుతాను. జస్ట్ 2 minutes సార్.
సార్ వచ్చిందా రాలేదో ఇంకా అది నేను అనేది
వచ్చినట్లున్నాడు. ఓకే సార్. సార్ లేనట్టు విల్ స్టార్ట్ ద
ఓకే ఓకే తర్వాత మాట్లాడి.
yes sir. Now I am requesting Professor KBL Subramaniam FIA Department of Civil Engineering, please start your talk.
Thank you IEI Telangana Center for giving me an opportunity to present.
అందరికి అన్మ్యూట్ చేయ బాబు. మ్యూట్ చేసే.
Okay. Thank you IEI Telangana chapter for giving me an opportunity to present. I
am requesting all please mute yourself. Yes sir.
Okay, thank you IEI Telangana chapter for giving me an opportunity to present, and thank you Rameswara garu for considering my for me for this endowment lecture, and let me start by sharing my screen. Right, so let's see,
full screen better sir.
Okay, so now I'm in the presentation mode, and again, thanks once again for giving me a chance to present. It's a topic that I'm very passionate about, and that is concrete structures and innovations that are taking place in concrete materials and concrete technology. And because sustainability has become a buzzword where we are all talking about sustainability, sustainable construction, I think it's important that we have to put things in a perspective, look for sustainable construction. So with this brief this thing, let me get started with where we are, where we were, where we are going. So if you look at construction, and I'm focusing at this moment on the super tall buildings, starting from 1930s, which is on the extreme right, to the extreme left, if you go, this is the tallest building on the planet today, which is Burj Khalifa. Now, one thing you see, of course, is that the skyline has steadily been increasing in height. And Burj Khalifa, to give you a point of reference, is about 850 meters tall. So it's almost a kilometer in height. Now, we are literally pushing the envelope here. So in terms of what we are able to achieve in construction, it is not just merely that we are going high, but we are actually pushing the envelope in terms of several technologies which need to concurrently be possible for us to put a man basically living happily at 850 meters, which includes, of course, the construction technology. Now, if you go to construction technology, starting in 1930s, most of the high rises or super talls are built with steel. The structural system was steel. As we start coming to the left, we start seeing, we start walking across in decades. So starting from 1930s, then we come to 1970s, 80s. So even up to 1990s, the material of choice for super tall buildings was steel. But something happened, and there was a major revolution in concrete. There was a major revolution in the way we were producing concrete, the way we were using concrete, the way we were actually able to place concrete. That if you start looking at 2004 Type A 101, which is this building, the green building that you see here, to the left of that, practically all the buildings have major structural system, or the structural system of those buildings is concrete. So concrete has now become the material of choice in these super tall buildings. And that has happened because we are able to develop technology to make concrete stronger. We're talking about concretes which are very, very strong today, concretes which are very ductile, because if you look at a super tall building like what you have here in Burj Khalifa, the wind pressures are so enormous at that height that just under the design conditions, Burj Khalifa, the top would sway almost 2 meters relative to the base. So now the materials have to be able to withstand that kind of lateral movement. So we are talking about concretes which are basically able to handle that kind of requirement for flexibility. And finally, of course, we are able to place the material so high. So now I have technology where I could be sitting on the ground floor and I'm able to pump concrete to a height of 800, 850 meters, even 1 kilometer. So that technology is also available now. And that is what has made concrete the material of choice going forward. Of course, concrete has inherent advantages over other construction materials. It is its cost. It is the cheapest construction material that you can possibly think of. Fire resistance, it is one of the best known materials when it comes to fire performance and fire endurance. So coupled with all of these things, now when technology is enabled, that gives us the performance and the ability to deliver the material at whatever height we are talking we want, we are now thinking of concrete as the material of choice for high-rise and super high-rise construction. So now if you look at some statistics and use of concrete, and if you look at the super tall structures, if you look at the 100 tallest buildings in the world today, 59 of them are in Asia and 23 are in Middle East, which leaves only 18 of them in the rest of the world, which basically tells us that the major action when it comes to super tall buildings is in Asia. That's where all the action is. For once now, the technology advancement, technology development, implementation is all taking place in Asia. We apply a magnetic field and cause concrete or produce concrete to flow. When we remove it, it goes into a set behavior. It sets and becomes starts behaving like a set material. So that is the concept of set on demand. So a lot of active work is going on set on demand using electric impulses and magnetic impulses. So that is basically all the different performance related improvements that are being sought and are being developed for concrete, including fresh and the in-service behavior of concrete. What are the challenges that we face? Cost is the primary challenge. Now that we're bringing in complex chemicals into the picture, it does increase the cost. Black box. A lot of these chemicals that are being produced for achieving specific improvements in performance basically are being developed by chemists, and they are black boxes. They're very complex chemicals. And because it involves chemistry and we are civil engineers, we basically find it very difficult to understand this, but which also means that it opens an avenue. Now, as civil engineers, we have to invest the time and energy to learn the chemistry, to be able to engineer the chemistry to deliver the performance that we are looking for. Drug interaction. Well, this is something which is we notice when we take multiple drugs, they can interact with each other and produce harmful effects. When I'm using multiple admixtures, they can interact and produce undesirable effects. So we need to understand how these different admixtures interact with each other. Government is another issue. Government and policy. Government policy has not kept up to speed with the development of technology. So as a result, the use of this new technology is in the government sector is lagging. So, and that basically creates a problem because government is the largest stakeholder in infrastructure. It is the largest owner of infrastructure in this country. So unless the government steps forward and starts encouraging adoption of this technology in a fast manner, it's not going to be adopted. And the final thing is the cost to benefit ratio. So now that we're talking about performance, I cannot start looking at things just based on cost. We cannot start thinking of things as merely L1. We have to think of cost over the service life of the structure. So cost to benefit ratio. And when we do that, we may spend a little bit more money today when we use this new technology. But in the long run, if I'm able to get a structure that lasts 200 years as opposed to 20 years, then basically over 20 years, my investment more than pays off. In fact, I'm better off putting in that little bit of a little bit more money today. So that is the kind of thinking that has to be developed, where we start looking at our civil engineering projects from a cost to benefit perspective, rather than a cost today or an L1 kind of an evaluation. So with that, I'd like to conclude and say that concrete is, it's not 1:2:4 concrete anymore. We've come a long way. Concrete is now a respected composite material with tailored delivery of performance. I can now make concrete, engineer concrete to deliver the performance that is required of any high performance material. And concrete technology is serious business now. So with that, I'd like to conclude with this slide here. This is a slide, this slide basically shows a car, it's a solar powered car. The chassis of the car is made of cement. 95% by weight of the material that went into making this chassis is cement. And this is a car that was actually produced with the cement-based material, which has a very high tensile strength. You see the solar panel on the back. It actually competed in this race, which basically traverses the continent of Australia under solar power. The car was entered as an entry from a cement company. It actually finished the race. So this is likely the vision of future for cement, where we're looking at cement and concrete as an engineered material. We can start producing cement components just like we do any other component made of steel or aluminum or ceramics. So with that, I'd like to thank you for your attention and take any questions that are there.
Thank you very much, sir. But no question answers for the endowment lecture, sir. Sir really explained very well about the concrete, sir, and challenges of cement product and carbon footprint with production and energy requirement, and also alternative cement production and challenges in construction methodology, performance-based high design, and performance measures in concrete, flow pumpability, and also high performance concrete and specification and performance required. Really, sir, it is almost you covered total subjects, sir. We have really enjoyed the talk, sir. With the few words, I'm requesting all of you, please give the big round of applause to our SUBRAMANIAM, sir.
Thank you. Thank you.
Now, I'm requesting that if Captain Janardhan sir is there, please talk 2 minutes only, sir. Already, sir has taken 1 hour, 10 minutes, 15 minutes, sir. You are really, without stop, 1 hour, 15 minutes you have taken time, sir. I generally, the endowment lecture will be only the half an hour, sir. Okay, anyway, everybody are with the interesting subject. That's why we all are enjoyed the talk, sir. Now, I'm requesting Captain Janardhan sir, please say a few words within 2 minutes, sir.
Okay. Good evening, everybody.
Good evening.
We just now heard endowment lecture of Sri Gurram Koti Reddy garu. I think it is appropriate time to remember his greatness and his great deeds in the irrigation department. I am fortunate enough to work as deputy executive engineer when he was SC Hyderabad circle. He was the real taskmaster. He was responsible for supplying drinking water to Warangal city in record time. Before he took over, the importance in work was given to economy in execution of work, irrespective of time consumed. The result was that contractors used to quote less rates and get the work, and then try to get the estimates boosted up by illegal ways. And when that was not possible, they used to abandon the work. So getting the balance work through other agencies at a higher rates, penalizing the first contractor was never an easy job. Finally, it resulted in abnormal delay in completion. So Mr. Koti Reddy changed this practice. He first got the estimates prepared at workable rates and told the tenderers to be careful while quoting. He told them clearly that all the contractors will be engaged on different reaches, so without any unnecessary competition between them. Thus, having good rates, they could deliver the work in time. Thereby, he could supply the drinking water from Lower Mane division to Warangal city, nearly 90 kilometers. But one thing, in record time he could give it, because the time was fixed by, in 83 by Ugadi, the work should be completed and water should be given, and he has given it in time. He never, but one thing is sure, but he never overlooked the quality of work. He was very strict for qualities. Finally, of course, unfortunately, he was retired at the age of 55 years only, because of change of service rules at that time, which were later again changed. And I remember on his retirement day, there was a meeting like this, and what I told I still remember, and the same thing I will repeat. I said, Yaddad Ajarati Shrestha Tatta Devyotaro Janaha Sa Yat Pramanam Kurute Lokasta Dhanvartate. Whatever the great men, whatever they do, that will be followed by others. And the standards set by them will be followed by others. Mr. Koti Reddy has set standards very well, and we will try to emulate whatever the thing he has followed. Thank you.
Thank you. Thank you very much, sir. Now I am requesting Engineer T. Anjaya, please propose the vote of thanks. Sir, Koti Reddy sir, son is there, sir. Satyanarayana Reddy, or please, if you want, talk 1 minute, 2 minutes. Satyanarayana Reddy. From his family member, Satyanarayana Reddy. Satyanarayana Reddy. Okay, now you propose the vote of thanks, Sanjay sir.
Respected chief guest, dignitaries on the webinar, distinguished guests, fellow fraternity, media friends, and family members of Koti Reddy Garu, ladies and gentlemen, it gives me immense pleasure to perform the pleasant duty of proposing vote of thanks. On behalf of Telangana State Center of IEI, I convey our sincere and profound thanks to Professor KVL Subramaniam Garu, Professor, Department of Civil Engineering, Indian Institute of Technology, Hyderabad, for making it convenient to this August presence and deliver the Engineer Gurram Koti Reddy second endowment lecture in a very lucid way on a very important topic. I convey our thanks to the guests, past chairmen of Institute of Engineers, past presidents, and joint honorary secretaries, and our friend Sri V. Jambul Reddy Garu, and our chairman, Dr. G. Rameshwara Garu, budding engineers who made it convenient to be with us to pay respects to Engineer Gurram Koti Reddy. I thank the managements of media for their continued support to all our endeavors and activities. I convey once again thanks to everybody.
Close with the Janaganamana.